All right, section 7-3, proving triangles are similar. All right, so let's start off with some review. We're going to write the converse of each theorem. So if the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. So the converse, if a parallelogram is a rhombus, then its diagonals are perpendicular. So if a point is perpendicular bisector of a segment, then it's equidistant from the endpoints of the segment. If a point is equidistant from the endpoints, of a segment, then it is on the perpendicular bisector of the segment. All right, so to verify something means to find the truth or accuracy of it. A proof is a way to verify a conjecture or statement. All right, so can I verify the two triangles are similar by showing that corresponding angles are proportional? False. I can use properties, postulates, and previously proven theorems to verify steps in a proof. True. Okay. So the angle-angle similarity postulate. If I know two angles of one triangle are congruent to two angles of another triangle, then the triangles must be similar. Side angle side similarity theorem. If an angle of one triangle is congruent to an angle of a second triangle, and the sides that include the two angles are proportional, then the triangles are similar. Side, side, side. If the corresponding sides of two triangles are proportional, then the triangles are similar. So write a postulate theorem that proves this thing is true. All right. So we had the sides in proportion, and we have congruent angles in between them. SAS. Similarity. All right. So are these triangles similar? Let's complete the diagram. All right, finishing these up here, this is going to be 51 degrees, and this is going to be 39 degrees. So yes, they are. Okay, we have at least two angles. We have actually three triangles, so these must be similar. Okay. All right, let's write the ratios of these things. All right, so for the first one, is AB to EF, what is that? That's going to be 9 to 12, which equals 3/4. The next one, AC to EG equals 6/8, which equals 3/4. And then I have BC over FG, which equals 6/8, which equals 3/4. All of these are the same. So I can use SSS to prove these are similar, SSS similarity. ABC is similar to triangle EFG. Okay. All right, proof is shown below. Write a reason from the box in each statement below. So how do I know AC is parallel to MP? Well, that was given to me. How do I know angle A is congruent to angle P? Well, parallel lines are cut by transversal, then we know alternate interior angles are congruent. Then how do we know angle ABC is congruent to angle PBM? Vertical angles. So then how do we know triangle ABC is similar to triangle PMB? Watch this. We have A and A. So we have the angle-angle similarity theorem. All right, why is it important that the ground be flat to use the method of indirect measurement illustrated in the problem below? So before rock climbing, Darius wants to know how high he will climb. So he places a mirror on the ground and walks backwards so he can finally see the top of the cliff. So here's the mirror right here. Mirror is right here. Okay, and then he wants to use similar triangles to find the height of this hill. If the ground is not flat, will angle HTV equal and JSV be right angles? No. If the ground is not flat, will you be able to find congruent angles? No. Why is it important that it's flat? So that we have right angles. Okay. So error analysis. Which solution for the value of x in the figure below is not correct? Okay, is it A or is it B? Okay, I don't know. Let's see which one's not set up. So let's do this. What's the shortest side in the larger triangle? 6. What's the longest side? X. And then the third side is 9. In the smaller triangle, 4 is the shortest side, 8 is the longest side, and 6 is the one in between. So comparing the ratios. So 6 goes to 4, x goes to 8, and 9 goes to 6. All right, cross out the proportion that does not show the ratios. This one does not show those ratios. Cross out the solution that does not have the ratios, solution A. So which one is not the correct value of A? And that would be solution A. And that's the end of this section.